Hi, I am Syed on Maths Online. Today's topic is unit step function, or we even call it as Heaviside function. Let me first define what unit step function means. Unit step function is represented in the form of u of t minus of a, or you can even call it as Heaviside function, which can be represented in the form of h of t minus of a. So it is defined as the unit step function u of t minus of a. Its value will be equals to 0 when the value of t is less than or equals to a, or the value of u of t minus of a will be equals to 1 when the value of t is greater than a, where this a represents a constant. That's the basic definition of a unit step function. Let us see some of the properties of unit step function. The first property over here, Laplace transform of the unit step function u of t minus of a will be equals to e power of minus of as divided by s. That's the first property. Now let us move on to the second property, Laplace transform of f of t minus of a into u of t minus of a is equals to e power of minus as into f bar of s, where this f bar of s is nothing but the Laplace transform L of f of t. So those are the two properties on unit step function. Now let us take few examples based on these properties. Let us take the first example. Question number 1. Find the Laplace transform of the function e power of t minus of 1 plus sine of t minus of 1 times of u of t minus of 1. That's the question you have. So find the Laplace transform of e power of t minus of 1 plus sine of t minus of 1 times of u of t minus of 1. So we try to observe the property that we have seen, property number 2. So in property number 2 you have Laplace transform of f of t minus of a into u of t minus of a. So this a particular expression that is given over here, it is in the form of f of t minus of a into, it is u of t minus of a form. If you try to observe the property that we have seen, Laplace transform of f of t minus of a into u of t minus of a. So if you try to observe what should be the value of a. So if you try to observe over here, it's t minus a. So a value is 1. So here also you can observe a value is 1. Here also you can observe that the value of a is 1. So instead of writing f of t minus of a, I can take this entire function to be equals to f of t minus of 1. So let me take the value of f of t minus of 1 to be equals to e power of t minus of 1 plus, it is sine of t minus of 1. So I've taken f of t minus of a to be f of t minus of 1 because the value of a is 1. So now if I try to convert this value in the form of f of t, which means I am replacing the value of t minus of 1 as t. So right hand side also, t minus of 1 will become t plus sine of t minus of 1 will become t. And we know the property of the Laplace transform, the property number 2 that we have seen, it is Laplace transform of f of t minus of a into u of t minus of a. Its property is nothing but its value is e power of minus of s into f bar of s. So right hand side, the only one thing that I need to calculate is f bar of s, and we know f bar of s is nothing but L of f of t. So the Laplace transform of f of t. So the only thing that I need to do over here is I need to find out the Laplace transform. So just apply Laplace transform on both the sides. So it will be Laplace transform of e power of t plus sine of t. So apply the Laplace transform individually. Laplace transform of e power of t plus Laplace transform of sine of t. So using the basic formulas of Laplace transform, it is Laplace transform of e power of at will be 1 by s minus of a. What is a? Coefficient of t is 1. So a value is 1. So 1 by s minus of 1 plus it is Laplace transform of sine at. Sine at is a by s square plus a square. But the coefficient of t is 1. So the value of a in this case is 1 divided by s square plus a square. A square is 1. 1 square will be 1. So we got the value as 1 by s square plus 1. So here this L of f of t is nothing but your f bar of s. Alright. So now we have got the property of unit step function. We'll try to use that property over here. So we know from unit step function the property L of f of t minus of a. So a value in this case is 1. So t minus of 1 into u of t minus of 1 is equals to, it is e power of, I'm just using this property over here. So e power of minus, a value in this case is 1. So 1 times of s into f bar of s. But we already calculated the value of f bar of s. You need to just plug in over here. So we'll be getting e power of minus of s into f bar of s is 1 by s minus of 1 plus 1 by s square plus 1. So we have got the Laplace transform of f of t minus of 1 into u of t minus of 1. But we know the value of f of t minus of 1. You can just plug in over here. You'll be getting Laplace transform of, the very first step I have taken, f of t minus of 1 to be equals to e power of t minus of 1 plus it is sine of t minus of 1 into this u of t minus of 1 as it is. So that will be our required solution. Now let us move on to the next question. Question number 2. Find the Laplace transform of, find the Laplace transform of so the function that is given over here is sine of t into u of t minus of pi. That's the question we have. So once again, if you try to compare this value with the property of the unit step function, so this particular expression will represent f of t minus of a, and this is nothing but u of t minus of a. So if you try to compare the value of a over here, a is what? A value will be pi. So this will be your pi value. So therefore, if I want to write down the function f of t minus of pi can be taken as what? Sine of t. But I need to replace this value of t minus of pi as t. So how to get this expression? So I'll just be adding plus pi. So if you try to add pi, so I can rewrite this as t minus of pi. I'll just add pi over here. It is sine of, here also I just add pi. So it is t plus pi. So on both the side I'm just adding pi, so that what happens is that this minus of pi and plus pi will cancel out. You will be left out with f of t is equals to this is nothing but your sine of t plus pi, or I can write pi plus t. So this represents sine of 180 plus theta form, and we know that sine of 180 plus theta is nothing but minus sine of t. Sine of 180 plus theta will be minus sine t, the basic formula. So if I try to use this one, I'll be getting minus sine of t, right? So once we have got f of t value, then I need to find out the Laplace transform. So apply the Laplace transform on both the sides, which will be equals to minus sign I can take outside. So I have Laplace transform of sine of t, so which is nothing but minus sine t. Laplace transform will be a value in this case is 1 by a square plus a square. A square, once again this coefficient of t is 1 over here. A square will be 1 square. 1 square is 1. So this L of f of t represents your f bar of s. So now if I try to use the unit step function property, Laplace transform of f of t minus of a into u of t minus of a will be equals to e power of minus of as into f bar of s. As we know that this value of a is pi, therefore I'll try to replace the value of a as pi. So Laplace transform of f of t minus of pi into u of t minus of pi is equals to, it is e power of minus, a value is pi, so pi times of s. F bar of s value has been obtained over here. I can write that as minus 1 by s square plus 1. Or if I try to replace the value of f of t minus of pi, so I'll be getting f of t minus of pi. Very first step I have taken over here, its value is sine t. So you'll be getting sine of t into u of t minus of pi will be equals to, you have a negative sign, so minus e power of minus pi s divided by s square plus 1. So that will be the required solution. Let us move on to the next question. Find the Laplace transform of the function is 3t square plus 4 times of t plus 5 times of, it is u of t minus of 3. So once again, if you try to observe, this represents your f of t minus of a, and this represents your u of t minus of a. So if you try to compare this value of a, so the value of a is 3. So you have to replace the value of a as 3 over here. So if you try to rewrite, let f of t minus of 3 will be nothing but 3t square plus 4 times of t plus 5. But here I need to get t, therefore what I'll try to do is, because minus 3 is there, to neglect this minus 3 I have to add plus 3. So to remove this minus 3 I need to add plus 3. So the right hand side also you need to add plus 3. So t plus 3, it becomes whole square plus 4 times of t plus 3 plus 5. So here this minus 3 and plus 3 will get cancelled. You will be getting the value as f of t is equals to 3 times of. This is in the form of a plus b whole square. You can just use the formula a square plus 2 times of a into b plus b square will be 3 square. So a plus b whole square plus. So here you just multiply this 4 inside. It's 4 times of t will be 4t. 4 times of 3 will be 12 plus this 5. Or further, if I try to simplify this expression, this 3t square plus it is 6 times of 3 will be 18t plus, so this 9 times of 3 will be 27 plus it is 40 plus 12 plus 5 will be 17. Or further, if you try to simplify, it is 3t square, just add the like terms, 18 plus 4, 18t plus 4t will be 22 times of t plus next you have 27 plus 17, its value will be equals to 44. So we got f of t value. Now we'll take Laplace transform. So Laplace transform of f of t will be equals to 3 is a constant, we'll take outside, is Laplace transform of t square plus it is 22 times of Laplace transform of t plus Laplace transform of the constant 44. Just try to apply the Laplace transform 3 times of the Laplace transform of t power of n. So we know the basic formula. Laplace transform of t power of n will be nothing but, if it is a whole number, you have the formula as n factorial divided by s power of n plus 1. So we'll try to use the formula. In the first case, your value of n is 2. So we'll be getting 2 factorial by s power of 2 plus 1 plus is 22. Here also you have to use the same formula, but here it is t power of 1. So the value of n in this case is 1. So it is 1 factorial divided by s power of n plus 1, 1 plus 1 plus, we know the basic formula of Laplace transform of a. Laplace transform of a will be a by s, the constant by s. So here a value is 44. So it is 44 divided by s. So let us further try to simplify this expression. This will be equals to 2 factorial is 2. 2 times of 3 will be 6 divided by s cube plus is 22 times of 1 factorial is 22 divided by s square. Then you have plus 44 by s as it is. So it is Laplace transform of f of t is represented in the form of f bar of s. We know the property of unit step function. Laplace transform of f of t minus of a into u of t minus of a is nothing but e power of minus of as into f bar of s. Initially itself I have shown you the value of a to be equals to 3. So that value will try to plug in over here. So Laplace transform of f of t minus of 3 into u of t minus of 3 is equals to, it is e power of minus of 3s and f bar of s is known from here. So it is 6 by s cube plus 22 by s square plus 44 by s. Or if I just try to replace this value of f of t minus of 3, initially we have taken f of t minus of 3 to be equals to 3 t square plus 4 times of t plus 5 into u of t minus of 3 is equals to, right hand side will be the same, it is e power of minus of 3s times of 6 by s cube plus 22 by s square plus 44 by s. That is the required solution. Let us move on to the next question. Find the Laplace transform of the function is t square minus 60 plus 9 times of e power of minus of t minus of 3 into u of t minus of 3. So now if you try to observe this expression, the product of these two will give you f of t minus of a, and this will be your u of t minus of a. So if you try to observe, the value of a in this case is 3, a is 3. So therefore I can rewrite f of t minus of a or f of t minus of 3 to be equals to, it is t square minus of 60 plus 9, it is times of, it is e power of minus of t minus of 3. But I need to get the value of f of t, therefore I'll just add plus 3 on both the sides. So here also wherever t is there, I'll just put as t plus 3. So it becomes t plus 3 whole square minus 6 times of t plus 3 plus 9 times of, it is e power of minus of t minus of 3 plus 3. So now you can just try to simplify. This minus of 3 and plus 3 will cancel out. Here also this minus of 3 and plus 3 will cancel out. So we will be getting f of t to be equals to, so this is the form of a plus b whole square. So it is a square plus 2 times of a into b plus b square will be 3 square. Just multiply minus 6 inside, minus 60 plus into minus will be minus, 6 times of 3 will be 18 plus this 9 value will be as it is times of, it is e power of minus of t. Or further if you try to simplify, it is t square as it is. Here you are having a plus 3 times of 2 will be 60. So this plus 60 and minus of 60 will cancel out, and you have over here 3 square is 9 plus 9 18 plus 18 and minus of 18 will cancel out. So those values will also cancel out. You are just left out with t square, it is e power of minus of t. So you got the value of f of t to be equals to t square into e power of minus of t. So this value we need to simplify with. So let us try to find out the Laplace transform of this particular expression. You can solve this in two ways. Either you can use the formula of Laplace transform of e power of at into f of t. That is one way you can solve, or you can solve the formula, or you can solve it by using Laplace transform of t power of n into f of t. So I will be using this particular formula, Laplace transform of e power of at into f of t. This is nothing but f bar of s minus of a. So if you try to see in one of my earlier videos, I have shown you problems based on this property. So let us use this over here. So first we will try to identify the value of f of t. So e power of at in this case will represent your e power of minus of t. So what does a value represents over here? A value in this case will be minus of 1. And what does this f of t represents? F of t represents your t square value. So if you want to find out the Laplace transform, let us take the Laplace transform both sides. Laplace transform of f of t is equals to Laplace transform of, I will first write e power of minus of t, then t square. So that, which means that whenever you have e power of at, the function will shift from s to s minus of a. So first I need to find out the Laplace transform of t square. That is what we need to do. So what will happen to this e power of minus at? That will be shifted. So s will be shifted to s minus of a. So in this case, what is the value of a here? Value of a is minus of 1. So s will be shifted to s plus 1. That is how we have to solve it. If you want to know more about this property, you can just watch my earlier video, which will be equals to. So now we need to find out Laplace transform of t power of n. we know Laplace transform of t power of n will be n factorial divided by s power of n plus 1. So therefore here n value is 2, so 2 factorial divided by s power of 2 plus 1, and the value of s is being shifted to s, minus of minus will become plus 1. So now you can replace the value of s as s plus 1, and along with that you can simplify. 2 factorial will be 2 divided by s will become s plus 1, whole power of 2 plus 1 will be 3. So we got Laplace transform of L of f of t. This represents your f bar of s. So we have got f bar of s value. Now if you use the property of unit step function, Laplace transform of f of t minus of a into u of t minus of a will be equals to, it is e power of minus of as into f bar of s. So now if you try to rewrite, it is Laplace transform of f of t minus of a value I have taken it as 3. So f of t minus of 3 into u of t minus of 3 will be equals to, it is e power of minus, the value of a we have taken it as 3. So it is 3 times of s into f bar of s value is over here, it is 2 by s plus 1 whole cube. 2 by s plus 1 whole cube. So if you try to rewrite this one, just plug in the value of f of t minus of 3. So you have got Laplace transform of f of t minus of 3 that I have taken is t square minus of 60 plus 9, that is the question, right, into e power of minus of t minus of 3 into this u of t minus of 3 will be as it is, that will be equals to, so it's 2 times of e power of minus of 3s divided by s plus 1 whole cube. That will be the required solution. That's all I have for today. Thank you.